Hi guys, welcome to your Unit 4 Lesson 2 notes on equations as relations. By the end of the day, you'll be able to solve linear equations for a given domain. Now remember that the domain represents all the x values of a function. So when you hear domain, think x values. So here's our key idea of the day. Our key idea is that when you're solving an equation with two variables, you want to find the solution, which will be an ordered pair. It'll be an x, comma, y, like that. So if you have a true statement when the numbers in an ordered pair are substituted in to your equation, then that ordered pair we call a solution to the equation. So after you plug it in, if this makes your equation true, then it's a solution. So let's do two examples. Here, we want to determine, is each pair a solution of this equation y equals 2x minus 1? Y equals 2x minus 1. So our very first step is to substitute our values into our equation. So we look for our x value, that'll be 0, and we look for our y value, that will be 1. And we plug in 0 and 1 for our x and our y. My hint for you is always write x, y above your point so you know what's what. Okay, so now we take 0 for x, and we take a 1 for y, and we say, is it true that 1 is equal to 2 times 0 minus 1? And since we're checking, I like to put a little question mark right there. Okay, well 2 times 0 is 0, and then we have minus 1. 1 equals 0 minus, well shoot you guys, 0 minus 1 is negative 1. And this is not true. So because this didn't work out, we say no, this is not a solution. Let's try our other one. Maybe that will go faster. Or sorry, not faster. Maybe it'll go better. So again, we've got our x and we've got our y, and we have our equation y equals 2x minus 1. So we're going to substitute 3 for our y and 2 for our x. We're going to say, okay, is it true that 3 is equal to 2 times 2 minus 1? Well, 2 times 2 is 4, and 4 minus 1 is 3. Yeah, that's true. 3 is 4 minus 1, so yes. Excellent. We say yes, this is a solution of the equation. Phenomenal. Okay, so now in our next one, we have a function here. We have y equals 3x. And we want to solve this function for the domain -2, -1, 0, 1, and 3. What that means is those are all your x values. So we're going to plug those in and see what we get. So we're going to plug in -2 into 3x. So wherever we have, oh, and by the way, this 3x, we say, goes right there. So wherever we have an x, we're going to plug our x value in. So 3 times x, here we have 3 times -2, because -2 goes in for x. And then 3 times -1, 3 times 0, 3 times 1, and 3 times 3. Now if y equals 3 times x, then we just say, okay, these are equal to each other. What does that mean? Well, 3 times -2, that equals -6. And 3 times -1, that equals -3. 3 times 0 is 0. 3 times 1 is 3. And 3 times 3 is 9. So now we have an x value and we have a y value. So we can plug those into ordered pairs, and that's what we call our solution set. It's the set of all of our solutions. Remember from earlier that a solution to an equation is any point that makes that equation true. So here our point is -2, -6, and then -1, -3, 0, 0. That's going to be fun. 1, 3, and 3, 9. Now all we have to do is graph each of these points. So our x values will go along our x-axis right here, and our y values will go along our y-axis up and down right here. So our first point, -2, -6, will go back 2 and down 6. This is -2. This is -2, -4. Oh shoot, we're just a little bit too far off our graph, huh? Right there. And then -1, -3 goes back 1, down 3. 0, 0 is right here at the origins where they intersect. We call that the origin. And then over 1, up 3. And this is 5. This is 10 up here. 1, 2, 3, up 9. Like this. Ta-da. And what's great about this is just extra fun learning for you guys, is we call this linear because it makes a line, and each of these connect in a line. Isn't that so fun? That's not always going to be the case, but this one happens to work out like that. Okay, cool. Now, what happens though if we don't easily see what y is? So this one was easy because it was what we say solved for y. Y was already by itself, so we can easily find out what is y. Sometimes it's not that straightforward, but we can make it like that. Right here, we need to solve for y. We need to get y all by itself. So let's isolate y. Let's solve for y. We have 4x plus 2y equals 8. And if we're trying to get y all by itself, let's undo what's happening to our y. So our first step is going to be subtract 4x from both sides. And then our 4x minus 4x, that'll cancel out to 0, giving us 2y equals -4x minus 8. I'm sorry, plus 8. That's plus. And then all we have to do is divide by 2 on both sides. Our dividing by 2's cancel each other out, so we get y equals -2x plus 4. And now that we've isolated y, we can easily find out what it is depending on what x is. Okay, so we know that whatever x happens to be, y is going to be equal to -2 times x plus 4. So to help us figure out what y is for each of these x values, let's substitute and find out. So whenever we have our x, we're going to plug those in for our x here, and that'll tell us what y is. So what I'm going to do, I'm going to do a little sneaky way. I'm going to copy this real quick, and it'll allow us to substitute some values in real fast. So whatever we have for x, we're going to plug that in right there. Oops. Okay, so if x is -2, then -2 times -2 is 4 plus 4 gives us 8. And next, if x is -1, then 2 times -1 is 2 plus 4 is 6. If x is 0, we plug that in right here. We have 2 times 0 is 0 plus 4 is 4. -2 times 1 plus 2 is 2. -2 times 2 plus 4 is 0. Now this gives us each an x, y pair. When x is -2, y is 8. When x is -1, y is 6. Our other points are 0, 4, 1, 2, and 2, 0. And now that we have each of these points, we can plug them in up on our graph, taking all of our x values, plugging them over here, and taking all of our y values, our y coordinates, and those will tell us how far up and down to go. So our points, we have -2 up, this is 5, 8, -1 up 6, over 0 up 4, over 1 up 2, and over 2 0, up nothing. And again, we can connect these in a line because they make one line, connects them all together. Whoops. Ta-da! Isn't that super? Super great. We call it a linear relation because they make a line. Fun fact. Okay, great, but when are we going to use this in real life? Well, let's say that you've got a rope and it's 40 feet long and you need to make a rectangular court to play either volleyball or soccer or tag because we're going back to elementary school. I don't know. There's some activity that you need. So you need a rectangular sports cart. Well, how much space can you use up? And we'll also remember that you have 2 times the width plus 2 times the length equals the perimeter of a rectangle. Now, when we have 48 feet of rope, that means our whole rectangle is going to be taken up by 48 feet. We need to figure out how wide our court can be with the given lengths. So since the widths, that's going to be what we are finding, we'll make that be our y value, and the lengths, or that'll be our range, and our lengths, since that's what we have, we'll make that our domain. So first, we're going to assume that all of our L's are our domains. Oh, hey, we just said that. So we need to solve for W. So we have our original equation, 2W plus 2L equals P. But we want to get W all by itself because that's what we're going to be looking for. It says find the widths. So to get W all by itself, our first step is going to be to subtract 2L from both sides. So we have 2W equals P minus 2L, and then we'll need to divide by 2. We get W equals, and then it's up to you how you want to write it. Let's just go with 1/2 of P minus 2L. Looks good to me. Except, guess what, guys? We know our perimeter is 48. So wherever we have P, we can change that to 48. So let's just do this down here, save us some time. So that means that W is 1/2 of 48. Oh, nice. This is going to be so nice. Minus 2L. Well, that's the same thing as 1/2 of 48 minus 1/2 of 2L. And 1/2 of 48, I'm going to move this up just a little bit. I said I'm going to move this up just a little bit. Okay, thank you. 1/2 of 48 is 24. And then 1/2 of 2L is just 1L. So there you go. W is 24 minus L. And going back into our problem, that should make sense. Let's carry this up here, and I'll take a little bit of extra time to show you why. So here, we know that our total blue lengths is going to add up to 48 in total. And so, since this is all 48, if we take half of it, because we're gonna make a rectangle, half of it should add up to 24. So whatever your length ends up being and whatever your width ends up being, 24 minus the length, that will give you your width. Okay? And then you can play whatever sport you want on it. Yay! Now why are we doing this? Well, guess what, guys? We're doing this because math is supposed to make your life easier. Instead of having to figure out working backwards from the perimeter every single time, we've set it up, no volleyball pun intended, so that you can easily find what your width needs to be so long as you know your length. So since our width is equal to 24 minus L, all we have to do is plug in L, and that'll tell us, hey, there's your width. That's how wide you need to make your court. Okay? So what if your court is going to be 3 feet wide? Long, 3 feet long. Then how wide, oh dear. Then how wide should you make it? Well, let's find out. We're going to substitute 24. We're going to substitute our length in for L. So whatever our length is, we're going to plug that guy in. So here, if we want our court to be 3 feet long, we say our width is going to be whatever 24 minus 3 is, which is 21. And if let's say our court is going to be 4 feet long, well, then our width of our court is going to be whatever 24 minus 4 is. That's 20. If it's going to be 8 feet long, it's going to be 16 feet wide. And if it's going to be 12 feet long, it's going to also be 12 feet wide. Oh, hey, square! It'll give us a square if it's 12 feet by 12 feet. Now let's use our square as an example. We have our court, and if it is 12 feet long and 12 feet wide and 12 feet long and 12 feet wide, then 12 plus 12 plus 12 plus 12, was that too many? That adds up to 48. So our perimeter is 48, which is exactly what we want. Nice. Let's check the second to last one as well. If it's 8 feet long and 16 feet wide, and 8 feet long and 16 feet wide, well, 8 plus 16 is 24, plus 8 is 32, plus 16 is 48. So yeah, our perimeter is still 48. We did it right. But we're almost done. We need to write this in a nice, easy, short way. So we're going to say, all right, if we have our lengths and we have our widths, let's write those in quick pairs. So it's either 3 feet long, 20 feet wide, 21 feet wide, I mean, or 4 feet long, 20 feet wide, or 8 feet long, 16 feet wide, which is honestly probably the best one to go to if you're looking for like a football field or something. And then finally, it can be perfect square, 12 feet by 12 feet, giving you a perimeter of 48 feet. There you go. Solve for equation, plug in your values, and find what you need. And that's how to use equations to express relationships. Remember, it's a solution if your x and y values make it true. So if you can plug in a value for y, plug in a value for x, and that gives you a true statement, then yes, this is a solution. Have a great time in your homework.